to first order differential equation. In this topic, we will learn 2.1 separable variable, 2.2 first order linear differential equation. Learning outcome for this topic, students should be able to distinguish between general and particular solution. B. Solve separable differential equation. The last one, solve first order linear differential equation by means of integrating factor. Definition: a simple type of differential equation is dy dx equals to x squared plus 9. We integrate it to produce the required solution. And a differential equation is one which relates an independent or dependent variable with one or more derivatives. And these are examples that explain the given words. Okay, so order is the highest derivatives in a differential equation. Okay, this one the definition for order. And then degree is the highest power of the highest derivative which occur in a differential equation. Okay, so first example, determine the order and degree of differential equations below. Okay, so differential equation, y to the power of 5 dy dx equals to x squared plus y. Okay, so the highest derivative. Okay, we go to the definition. The order is the highest derivative and the degree is the highest power. So the order, okay, you order the highest derivative. So this one, the highest derivative. Okay, power of 1. Okay, highest derivative. So the order equals to 1. And then degree is the highest power of the highest derivative which occur in differential equation. So that means this one the highest power. Okay, the highest power is 1. And then the second one, the highest derivative. Okay, the highest derivative is 2. Okay, this one the highest derivative. That's why the order equals to 2. And then the degree for the highest power is 1. So that's why the degree equals to 1. Okay, so the highest derivative for example 3. Okay, this one we have the highest the order equals to 3. Okay, this one equals to 3 and the highest for degree is equals to 4. Okay, this one the degree. Okay, next the highest derivative is 1. Okay, this one the highest derivative equals to 1 and the highest degree equals to 3. Okay, so next the second last one is the highest derivative is 2. Okay, the highest derivative is 2 and then the highest degree. Okay, the highest degree equals to 4. And the last one, the highest derivative equals to 1. This one the highest derivative. And then the power, that means the degree equals to 5. Okay. Okay. In this chapter, we only deal with first order and first degree differential equation. Okay, how do we solve first order differential equation? So there are two methods which can be solved to solve first order differential equation. So they are separable variable and integrating factor. Okay, the first one, differential equation with separable variable. Okay, differential equation with separable variable. The separation of variable method is used when a differential equation can be separated algebraically. So step to solve the differential equation with separable variable, we have the only two steps. The first step is separate the variable x and y. That means x by the side of dx and y by the side of dy. The second one is integrate both sides independently. Okay, and then there are two types of solution. The first type is general solution. That means general solution of a differential equation contains an arbitrary constant c. Then particular solution of a differential equation contains a specific initial value problem, and then containing no constant. Okay, so example 2. So we have two terms exclude constant. So 1, 2, 3. Okay, we have two terms exclude constant. So normally we can solve by using separable variable. This one the constant. Okay, so we have the 1 and 2. Okay, so we can use the separable variable, and then we try to separate the variable x by the side of dx and y by the side of dy. Okay, so we try in y squared dy equals to negative x squared dx. Okay, separate the variable first, and then the second one is integrate both sides. Okay, we can integrate both sides. Okay, so integrate for left hand side, we get y cubed. Okay, integrate y squared, we will get y cubed over 3 equals to integrate negative x cubed, we get negative x to the power of 4 over 4 plus c. And then we find y as a subject. So y cubed equals to negative 3 over 4 x to the power of 4 plus 3c, that means c. Okay. Okay, we call this one the general solution because we have arbitrary constant c. Okay. So next, b, sin x over 1 minus y dy dx equals to cos x. Okay, so this one we have two terms. Okay, 1, 2. So we can use the separable variable. Okay, so first try to separate the variable first, then separate the variable sin x dy dx. Okay, this one is question 1 minus y equals to cos x. Then separate. Okay, separate x by side of dx and y by side of dy. Okay, so cos x, okay, over sin x dx. Make sure dy and dx berada pada numerator, and then 1 over, okay, this one 1 over 1 minus y dy. Okay, then the second step is integrate both sides. Okay, integrate both sides. Okay, so the left hand side we integrate, we get 1 over ln. Sorry, 1 over 1 minus y dy, we get ln 1 minus y, okay, over negative 1. This one over negative 1. So we get negative ln 1 minus y. Okay, equals to integrate cos x over sin x. We can use the properties or you can use the substitution method. Okay, so maybe you can use the properties. Okay, differentiate d dx. Okay, differentiate d dx. Okay, sorry. You can use the properties d dx f prime x over fx equals to ln fx. Okay, okay. So you differentiate sine, we get cos. So that means we get ln sine x plus c. Okay, by using the properties, and then you can use those substitution method. Okay, so then you find y as a subject. Okay, so ln 1 minus y to the power of negative 1 equals to ln sin x plus c. Okay, then we get ln 1 over 1 minus y equals to ln sin x plus c. Okay, then try find y as a subject. We get, try to exponent both sides. Okay, exponent both sides. So exponent ln, we get exponent ln 1 over 1 minus y equals to exponent ln sin x plus c. Okay, so by using the properties, we can simplify. So, simplify exponent ln, we get 1 over 1 minus y equals to exponent ln sin x plus c. That means we get exponent ln sin x, okay, dot exponent c. Okay, dot exponent c. That means exponent c we can use as a. Okay, so 1 over 1 minus y equals to exponent ln. We can simplify, equals to sin x. Okay, sin x multiplied by exponent c equals to a. So 1 over 1 minus y equals to a sin x. And then find y as a subject. So 1 over a sin x equals to 1 minus y. Then y equals to 1 minus 1 over a sin x. Okay, this one we call the general solution. Okay, next example 3. Find the particular solution of the differential equation 1 plus sin square x dy dx equals to exponent negative 2y sin 2x, where x equals to 0, then y equals to 1. Okay, this one, first calculate the terms. Okay, we have 2 terms, so normally we can solve by using separable variable. Okay, so separate the variable first. Okay, we can separate exponent negative y. Make sure dy on the numerator. Exponent 2y dy. Okay, exponent 2y dy equals to sine 2x over 1 plus sine square x. Okay, so we separate dia punya variable first and then integrate both sides. Okay, the second step is integrate both sides. Okay, so this one miss your dx. Okay, sorry, miss dx. Okay, so integrate both sides. For left hand side, we integrate exponent 2y. Okay, exponent 2y, we get exponent 2y over 2 equals to integrate sine 2x over 1 plus sine square x dx. Okay, maybe you can use the substitution method or you can use the formula. Okay, the formula differentiate f prime x over fx, you get ln fx. Okay, so maybe we can use the substitution method. First, u equals to 1 plus sine square x. Okay, then differentiate, you get du dx equals to 2 sine x cos x. And then du as a subject, 2 sine x cos x dx. Okay, so sine 2x, by using trigonometry properties, sine 2x equals to 2 sine x cos x. Okay, so integrate 2 sine x cos x over 1 plus sine square x dx. Okay, so 1 plus sine square x, you get u. Okay, this one u. And then du equals to 2 sine x cos x dx. This one du. Okay, du. So integrate du over this one, we substitute as u. Okay, so for left hand side, e2y over 2, sorry, e2y over 2 equals to integrate 1 over u. Okay, integrate 1 over u du, that means you get ln u plus c. Okay, for left hand side, we just copy. Okay, and then don't forget substitute u equals to 1 plus sine square x. So ln 1 plus sine square x plus c. Okay, so this one we call the general solution, e2y over 2. Okay, this one we call the general solution. And then the condition is given where x equals to 0, this one x equals to 0, then y equals to 1. You just substitute the value of x. Okay, when x equals to 0 and y equals to 1. So substitute your x. This one x. Then the value of y. Okay, equals to 1. So E2 multiplied by 1 over 2 equals to ln 1 plus sine square 0 plus c. And then you get the value of c equals to exponent 2 over 2. Then we substitute the value of c into general solution. We will get the particular solution. Okay, this one you call the general solution. Then substitute the value of c into general solution, we get the particular solution. So e to y over 2 equals to ln 1 plus sine square x. Okay, then substitute the value of c, exponent 2 over 2. Okay, then try to find y as a subject. So e to y equals to 2 ln 1 plus sine square x plus e power of 2. Okay, then find y as a subject, exponent, then ln both side. Okay, ln both side to eliminate the exponent, so you get 2y equals to ln in bracket 2 ln 1 plus sine square x plus exponent 2. Okay, then y equals to 1 over 2 ln 2 ln 1 plus sine square x plus exponent 2. We call the last solution is a particular solution. Linear first order differential equation. Okay, a linear first order differential equation is one of the form dy dx plus pxy equals to qs. Normally we have 3 terms. Okay, the solution must be on the interval where both px and qs are continuous. Then the usual solution to the differential equation is to change it to an exact equation by means of an integrating factor. Okay, so step to solve the differential equation by means of integrating factor, we have 6 steps. Okay, we can simplify. And then the first step is S. Okay, S. That means standard form. Okay, S is standard form. Okay, the standard form is dy dx plus pxy equals to qx. Okay, this one the standard form. Make sure your coefficient of dy dx is positive 1. Okay, the second step is I. Okay, I find the integrating factor. The integrating factor is Vx equals to exponent integrate of Px dx. Okay, I is integrating factor. The third step is M. M is multiply. Okay, multiply both sides of equation with Vx. You just multiply Vx both sides. Then next step is P. P is a product rule. Okay, you just simplify. Just simplify d dx, Vx multiplied by y, and the right hand side you just copy Vx multiplied by Qx. The next step is integrate both sides. That means I. Okay, I integrate both sides. Okay, don't forget follow by dx and followed by dx. Then the last step is y. Okay, y, state y as a subject. Okay, we go to example 4. Find the general solution of the differential equation dy dx plus 2y over x plus 1 equals to 0. Okay, so first make sure the equation in the standard form. Okay, so dy dx equals to positive 1, and then the standard form is dy dx plus pxy. Okay, pxy equals to qx. This one is standard form. So first step, we have s. Okay, as standard form. Dy dx plus 2y over x equals to negative 1. This one the standard form. And the second one is I. I is integrating factor. So integrating factor, we have formula exponent integrate of px. Px is coefficient of y. Okay, coefficient of y. So 2 over x dx. Okay, so exponent integrate to x. 2 over x, we get 2 ln x. And then you just simplify exponent ln x square, and we get x square. Okay, so your Vx equals to x square. Okay, next, third step is m. Okay, m, that means multiply Vx both sides to standard form. Okay, you just multiply x square multiply by dy dx, okay, plus x square multiply by 2y over x equals to x square multiply by negative 1. Okay, so this one the third step. And then step number 4 is P. P is product rule. Okay, so product rule, you just simplify d dx. Okay, d dx. Okay, Vx. Vx, that means your x square. Okay, multiply by y. Multiply by y equals to, and then the right hand side you just copy negative x square. Okay, next, step number 5 is integrate both sides. Okay, don't forget integrate both sides. We have number 5, integrate both sides. So when integrate, followed by dx. Okay, integrate followed by dx. Okay, so next, number 5, we call the integrate. Okay, so integrate this one. So we get integrate and differentiate. We get x square y. Okay, we get the original equation equals to integrate of negative x square dx. Okay, so we just continue x square y equals to integrate right hand side. We get negative x cubed over 3 plus c. Okay, so this one the step number 5. And the last step, 6 y as a subject. Okay, so you find y as a subject. Y equals to negative x cubed over 3 divided by x squared. So we get negative x over 3 plus c over x squared. Okay, this one the final step. Okay, so this one general solution for this question. So next we go to example 5. Example 5, the gradient of the curve is given by x plus y over x plus 1. So the meaning of gradient is dy dx. Okay, is, that means equal. So the equation is dy dx equals to x plus y over x plus 1. So find the equation of the curve which passes through the point 0, 2. Okay, the condition is given, that means the equation and then the solution must be in particular solution. Okay, so first we have 3 terms. Okay, you get 1, 2, 3. So normally we can use the integrating factor. Okay, so first the first step for integrating factor is standard form. So don't forget your standard form is dy dx plus pxy equals to qx. Okay, so the first step is standard form. Dy dx minus y over x plus 1 equals to x. Okay, this one is standard form. Okay, make sure the coefficient of dy dx equal to positive 1. And then the second step is I. I is integrating factor. Okay, integrating factor, we have Vx equals to exponent integrate of Px. Px, that means coefficient of y. Coefficient of y, that means 1 over x plus 1. This one, 1, y, right? So 1 over x plus 1. Okay, then don't forget negative. Okay, negative. Okay, negative 1 over x plus 1. Okay, so exponent integrate negative 1 over x plus 1, we get exponent negative ln x plus 1. Okay, and then don't forget simplify exponent ln x plus 1 to the power of negative 1. And then by using properties of, we can simplify, we get 1 over 1 plus x, 1 over x plus 1. Okay, this one, the value of Vx. Okay, so next we have the third step is M. Okay, M, just multiply your Vx into standard equation. Okay, so 1 over x plus 1 multiply by dy dx. Okay, dy dx minus, okay, this one your Vx, 1 over x plus 1 multiply by y over x plus 1. Okay, equals to 1 over x plus 1 multiplied by your x. Okay. The red color is your Vx. And then step number 4 is P. P is product rule. Product rule, that means T dx, then Vx multiplied by y. So your Vx is 1 over x plus 1 multiplied by y. Okay, multiplied by y equals to the right hand side, you just copy. Okay, just copy x over x plus 1. This one right hand side. Okay, next, step number 5 is I integrate both sides. Okay, so integrate, don't forget, followed by dx. Integrate, followed by dx. Integrate, followed by dx. Okay, so left hand side, we get integrate and differentiate. We get 1 over, or maybe we can use y over x plus 1. This one left hand side equals to integrate of x over x plus 1 dx. Okay, so for right hand side, how to integrate x over x plus 1 dx? Okay, how to integrate? So we can use maybe the substitution method, or we can simplify first. Okay, so simplify, maybe we can use the long division first. Okay, x over x plus 1. You get 1 x plus 1, and the remainder is negative 1. So how to write? We get 1 minus 1 over x plus 1. Okay, so before we integrate, we simplify first. Okay, we get 1 minus 1 over x plus 1. Okay, followed by dx. And the left hand side, we just copy. Okay, so integrate 1. Okay, this one integrate respect to x. We get x minus integrate 1 over x plus 1 dx. We get ln x plus 1. Then plus c. Okay, so left hand side, y over x plus 1. Then the last step, number 6, is what? Okay, y as a subject. So you just find y equals to x plus 1 in bracket x minus ln x plus 1 plus c. Okay, this one is called the general solution. Okay, but the question, the condition is given. That means your point x equals to 0, just the value of x, and then 2e value of y. Okay, then you substitute. The curve passes through the point 0, 2, x equals to 0, y equals to 2. This one the condition, right? So just substitute the value of y equals to 2, and then the value of x equals to 0. Okay, and then we get the value of c. Okay, 2 equals to 0 plus 1, 0 minus ln 0 plus 1 plus c. And then calculate, we get c equals to 2. And then you substitute the value of 2 into general solution, we get the particular solution. And the last step, y equals to x plus 1 multiplied by x minus ln x plus 1 plus 2. Okay, this one we call the particular solution.